I'm Anil Kumar sharing with you a very important concept about relative velocity and its application to vectors. The question here is, how is velocity of airplane, wind velocity, and relative velocity of plane with ground connected? I've been asked this question so many times, and so I thought, let me just make a video to explain the whole thing. So let's consider the velocities of these things as, let's say, Vp as velocity of plane. Let me give it some value. Let us say it is 400 kilometers per hour, and let's also give some direction to this, right? It's a vector after all, so we'll give it direction as from north, let's say 30 degrees east. Now let's define wind velocity. So this is my wind velocity. Wind velocity, let's give it a number. Let it be, let's say 60 or make it higher. Okay, 80 kilometers per hour. That's kind of very high winds. And let me use a different way of representing the angle. So I'll address two questions at the same time. So let me call this as from a bearing off. So you could also represent angles in terms of bearing off, and normally whenever you're working with navigations, you normally use bearing angles. They should be written always in three places, right? And these are from north, correct? And the question here is to find the ground velocity. So Vg is velocity of plane with respect to, let's say, ground. So if there is an observer on the ground, what velocity of plane or what direction will the observer see? That is what we are trying to figure out, right? So this could also be treated as a resultant velocity. So we also treat this as a resultant velocity. So resultant of these two is what the observer sees from the ground. So that is the connection between all the three. I hope this point is clear, right, with this. So when we're talking about velocity of airplane, velocity of wind, relative velocity of plane, or the ground connection of it, resultant velocity is what is the velocity of plane with respect to ground. Okay, so these are the two things very much connected, right? Now to get the resultant, it's a good idea to make a diagram, right? So let's make a diagram, then we'll work it out. So let's say this is our north-south, and then this is east-west, okay? So let's see how to sketch these things. First one here is velocity of plane, which is 400 kilometers per hour from north, 30 degrees east. So let's say that's the plane. 30 degrees will make an angle from here, 30 degrees, and then the magnitude is represented by 400. So that is the plane, okay? So we can write this as 400 here, the magnitude part, and that is the angle from north. So this is north for us, right? So this is north, this is east, south, and west. Is it okay? So that is what represents plane velocity. Now wind is 80 kilometers per hour, so it hits there and moves the plane towards this side. But normally what you should do is always represent the velocities or any vectors from the origin, right? So here we'll say 80 kilometers per hour, bearing of 130 degrees. 130 degrees is from north, right? So from north, this is 90 plus 40. 90 plus 40 is 130. So let me show that wind velocity as kind of like this. So it's relatively small. The magnitude this much is, let's say, 400. So that is kind of less than 1/4. So that represents my wind velocity. Is it okay? So that is how we get it. Now, of course, the resultant will be, you could do parallelogram here. So you can construct this part, which is parallel to this, and also this part, right, which is parallel to that. And so you get your resultant, which is VR for us. that is the velocity. We'll call it VR, right? Or I mentioned ground velocity, which is same as resultant velocity. Is that okay? So that is the resultant or the ground velocity which we have to figure out. So that becomes now an interesting question to work with, right? So we are saying this whole thing is how much? 130 degrees. So if this whole thing is 130 degrees, how much is this small angle in between? Since that is 30, we can say that, okay, so let me redraw this diagram just to show, or it's okay, we can work on it. So we know this whole thing is 130, and this part here will be how much? 130 take away, so let me write this here. So it is 130 degrees, take away 30 degrees, correct? Which is 100 degrees. Is it okay? So this part is 100 degrees. Or let's put some A, B, and let's say this is C. Okay, now it becomes easier to express. Fine. So what we have here is that the angle AOB, we have angle AOB as equal to 130 minus 30 degrees. 130 minus 30 degrees, which is 100 degrees. Now in this parallelogram, if this is 100 degrees, what is going to be that angle? Well, these two sides are parallel. That's the transverse line. This makes a C, right? These makes a C. It has to be 80 degrees, right? So the angle that gives you the angle OAC as equals to 180 degrees minus 100. That is 80 degrees. Is it okay? So we get this as 80 degrees. So what we have here is we have a triangle here whose one side is 400, angle is 80, the other side is, well, 80 kilometers per hour. So don't get confused with these numbers now. So that is kilometers per hour, and this is in degrees. Okay. So basically we have a triangle whose two sides and included angle is given. So we can find the resultant using cosine law, right? So we can use cosine law to solve this. Is it okay? Okay. So we find that OC, which is the resultant, should be equal to OC, let's write square, is equal to square of these two, which is 400 square. I'm not writing the formula for cosine law, but this square plus that square, which is 80 square, minus 2 times 400 times 80 times cos of angle between them, which is 80 degrees. So let's use the calculator, calculate this out. 400 square plus 80 square minus 2 times 400 times 80 times cos of 80 equals to. So we have a very big number, and OC will be equal to square root of this number. So let me write down here 155,286.5, whatever. Now, so this is it. So we do square root of this number. Square root of answer equals to 394. We'll take this 394. Okay. So we get 394 kilometers per hour as the resultant, right? So OC, which is right there, is 394. So the magnitude of the ground velocity or the resultant velocity, since they are velocities, okay, is 394, correct? So we know that part now. Now the question is, what is the angle which it makes with the resultant makes with, maybe from the north or maybe from this side. Any side you could work this out. Is it okay? So to find this angle, you could find this angle, for example. So to find the angle, let's say this angle is theta, right? We'll add 30 degrees to write it from the north. We could use sine law, right? So let's use sine law now to find angle. Okay. So that is, we want to find this angle. We say sine theta over what is given to us opposite to it is 80 kilometers per hour. We know that angle and the resultant now. So that angle is 80 degrees. So sine of 80 degrees divided by the resultant, which is 394. So we can say this implies theta is equals to, let me write straight this time, sine inverse of 80 times sine 80 degrees divided by 394. Does it make sense to you, right? So let's calculate this. Okay, so I prefer to do inside first and then do sine inverse, right? So we have 80, okay, divided by 394 equals to times sine 80 equals to. So we get some number and we'll do sine inverse of this, right? So shift sine inverse of the answer, and that is equal to, it gives us 11.5 degrees. Let's take this, okay. 11.5 degrees. So theta is 11.5 degrees. So what we can say now, since this is 11.5 degrees, from bearing angle will be 30 plus 11.5. Is that okay? So what I'm saying is that the angle is, okay, so bearing angle, let me write. Bearing angle, which is from north, will be 30 degrees plus theta, which is 30 plus 11.5 or 41.5. Is that okay? So we got the angle and also the magnitude, and therefore we can clearly write down the resultant velocity, which is the ground velocity. We could write resultant velocity. It is, magnitude was how much? 394, okay? 394 kilometers per hour at a bearing of 41.5. So we'll write this as 041. Always when you write bearing angles, use 3 digits, 0.5 degrees. So I hope in this video you have learned a couple of things. Vector addition is what you learn. Representing vectors is what you learn. How to work with relative velocity, velocity of plane, velocity of wind, and how do we understand the velocity of plane with respect to ground. That is basically the resultant velocity, right? So I'm Anil Kumar, and I hope you like it. You can put some likes there if you want, share your comments, and if you have any questions, feel free to post them. Thank you and all the best.